All right, we're going to talk about the refrigeration effect of ice. This is melting ice procedures. This is my favorite part of the weekend, HVAC or electrical, because it's the part I think helps people the most. Over and over, people tell me, I struggled to understand this before, and now I finally get it. So if you've had trouble with understanding melting ice procedures, this hopefully will clarify things a lot. I'd love to take credit for what I'm going to show you, but it was not my idea. This is the way Julian showed me, and it works and it makes sense. I need you guys to draw a little picture for me. Don't worry, it's not complicated. I am the worst artist you'll ever meet. I can't make a convincing looking stick figure. So you don't have to be an artist. All I want you to draw is basically 3 steps. Because this is a 3-step process. Okay? When we're melting ice, we've got to consider 3 different stages of this. On this first question, it says, how much heat is required to melt a 20-pound block of ice that's sitting frozen at 4 degrees Fahrenheit, given that the heating temperature is 45 degrees Fahrenheit. So we're going to treat this like we think of temperature. We think of temperature as going bottom to top, low to high, right? Or high to low, top to bottom. So we're starting at 4 degrees down at the bottom, and we're going to end up at 45 degrees at the top. And in between 4 and 45, this is not a trick question. There is an obvious temperature we have to address what happens at. What temperature is that? What's the magic temperature when we're dealing with melting and freezing ice? 32. Like I said, it's not a trick question, it's obvious. We have to address what happens at 32 degrees because that's where the transition takes place. So, for melting ice procedure, here's what we have to do. Step 1, we have to take our ice and we have to warm it up to 32. Because if it's not at 32, it can't melt yet. So the first step is warm the ice. I'll even write it this way. Step 1, warm the ice. Step 2, melt the ice. It makes sense, okay? There's no secret to it. It's obvious. Step 3, warm the water. That's how we're going to solve this. We can't do anything with it till it hits 32 in terms of melting it, so we've got to warm it up to 32 and then warm it up to 45. Ice can exist at any number of temperatures below 32. We just got to get it up that high. Okay? So step 1, we're going to raise this from 4 degrees up to 32. Here's how it's done. You take however many pounds you've got, and you're going to multiply it by the change in temperature. How many degrees do we want to warm it up? Okay? Number of pounds times the change in temperature. Then we have to multiply it by something called the specific heat of ice. Okay? I'm going to write this here because we need to know what the specific heat of ice is. The specific heat of ice is how much energy, how many BTUs does it take to heat up 1 pound, 1 degree. Okay? And it takes 1/2 of a BTU. So if it takes 1/2 to heat up 1 pound, 1 degree, we need to multiply that 1/2 times our number of pounds and number of degrees. Make sense? If it's half per pound per degree, we multiply half times how many pounds times how many degrees.
That's 10.
Do what?
That's 10.
You're on the way. Yeah, you're on the right track there. So let's start with 20 pounds times our change in temperature. We're trying to go from 4 to 32. What is the change in temperature from 4 to 32? How many degrees is it? 28. We're trying to raise this 28 degrees to go from 4 to 32. So we're gonna take our 20 pounds times 28 degrees times our specific heat. That's step
Pacific
one.
heat stays the same?
I'm sorry?
Pacific heat stays the same no matter what?
If it's ice, it will change when it's water. Okay? It takes more energy to warm up water than it does to warm up ice. Okay? And we'll do a couple of these, so if you're a little confused, you'll catch on. Basically, here's a good way of thinking it. Pounds times change in temperature divided by 2. Cut it in half. Okay? It's a half, so times 1/2 and divided by 2 are the same thing. So our pounds times change in temperature divided by 2. Well, half of 20 is 10. 10 times 28 is going to be 28 with a 0. It's going to take 280 BTUs to warm up a 20-pound block of ice 28 degrees. Doesn't matter the order you can do it. You can take half of 28 is 14. 14 times 2 is 28 with a 0, 280. Still going to work. Okay, that's step one. Pounds times change in temperature times 1/2. Because it takes half a BTU to warm 1 pound, 1 degree. Okay? Now what we have is we have a 32-degree frozen block of ice after 280 BTUs are applied. So step 2, we need to melt the ice. We do that by taking our pounds and we've got to multiply it by what's called, you don't need to remember this, I'm just going to write it down so you know what it is. You don't need to remember the term. Latent heat fusion. Latent heat fusion is how many BTUs does it take to melt 1 pound of ice? Okay? And we'll simply multiply it by how many pounds we have. This has nothing to do with square inches and square feet. It just happens to be 144 BTUs. Okay? So what this is saying is, at 32 degrees, it takes 144 BTUs to melt a 1 pound block of ice and stay 32 degrees. Because it can be water or ice at 32. Right? So we simply have to multiply how many pounds times 144 BTUs. You with me? 144 per pound, we have 20 pounds. 2 pounds would be 288, so on. So 20, 2 times 1 is 2, 2 times 4 is 8, 2 times 4 is 8 with a 0. Again, take a few seconds, put it in the calculator, even though this is easy math. Put it in the calculator because you're going to end up making mistakes after a long time. So here's what we've got so far. We have a 4 degree block of ice. After 280 BTUs, it's now a 32 degree block of ice. At that point, we multiply it by our latent heat fusion of 144. We apply 2,880 BTUs, and now it's a puddle. It's a 32 degree bucket of water. Okay? Now we have to warm it up to 45. And this is just like this step, except our specific heat changes. Okay? Because it takes more energy to heat water than it does ice. The nice thing is, the math is easier. Because the specific heat of water, I believe, is how we define a British thermal unit. It takes 1 BTU to warm up 1 pound of water at 1 degree. So you really don't have to do anything. You're just going to take your pounds times our change in temperature. Then you multiply it by 1, it doesn't change. So really it's pounds times change in temperature, pounds times change in temperature divided by 2. That's the difference between step 1 and step 3. Step 2 is just pounds times 144. You with me? 20 pounds times our change in temperature, we're going from 32 to 45. So what's our change in temperature? 13 degrees. 20 pounds times 13 degrees. 2 times 13 would be 26 with 0. Times 1, still 260 BTUs. So, it takes 280 BTUs to warm it from 4 to 32. It takes 2,880 to melt it, and it takes another 260 to warm it up to 45. How do we get the total? Add them up. 2,880 plus 280 plus 260. $3,420 BTU.